Hello further mathematicians. I'm going to go through some revision of paper 1, things you may have forgotten while you've been revising for ordinary maths or for your other subjects. Okay, so the first one I'm going to go through is dividing a number into a given ratio. Okay, so we're going to go to formula. So I'm just going to quickly whip up the formula here. So if you have a point here, x1, y1, and you have another point here, x2, y2, and it's been divided into a given ratio. Let's call this therefore m and n, and if we call that point A, B and C, where the ratio of A to B and B to C, A to B to B to C is in the ratio P to Q, we can find that coordinate by using this formula. We take the first x value and multiply it by the second part of the ratio and add it to the second x value that's been multiplied by the first part of the ratio divided by the ratio added together. And we'll repeat that for y. So y1 is the second part of the ratio plus y2, the first part of the ratio, divided by p plus q. That gives us that. You can pause the video and copy that out, but I'll be using it now to answer this question. So in this question we have that middle point, so I'm going to be doing some algebra, making an equation to find out what my original x2, y2 was. Okay, so to get the 5, they must have done 3 multiplied by the second part of the ratio, so let's rub that out. 3 multiplied by the second part of the ratio, so that's 3 times by 2, added to the second x value, which we don't know, that's x2, multiplied by the first part of the ratio, and they divided that by the ratio that added the two parts added together, which is 7, and it came out as 5. So I'm just going to solve this equation here. So I've got 6 plus 5x, I can just call it x actually, it doesn't matter if it's the second one because there's only one that we need, equals 7 times 5 is 35. So I'm going to subtract 6 from both sides, and I get x equals 29 over 5. That's my x coordinate. You can pause it and try it for the y. And I'm back again. So for the y, let's put that there for the x. I have the first y value times the second part of the ratio added to the second y value multiplied by the first part of the ratio over 7, and that came out as 5.5. So I'm going to be working out 14 plus 5y equals 5.5 times 7, so it's non-calculator, so I'm just going to quickly do 55 times by 7 here, over here like this. So that's 38.5, and then I'm going to subtract 14 on that and divide by 5, all without a ratio calculator. So I'm just going to do 24.5 divided by 5. Gives me 4, gives me 4.9, and that just looks a bit weird, so I'm going to quickly divide that up. So that gives me 5 wholes and 4 fifths, which is 5.8. The next question I'm going to go through involves the area of a rhombus, which can be split into two congruent triangles. Remembering we're given this formula, the area is half AB sine C. Okay, so you can pause the video and have a try. Our rhombus has all equal sides, so I know that that is also 8 centimetres. So if I divide that by 2, I have two congruent triangles. So the area of one of them would be half A, B, sine 60. And then we have to remember that sine 60 is root 3 over 2. So I've got a half times by 64 times by root 3 over 2. So we're doing all this without calculator, so I'm going to look for some tricks. 64 divided by 2, just do that part here, is 32 times by root 3 over 2. And then I'm going to divide that by 2, gives me 16 times root 3. So that gives me one of those triangles. I've only found 1/2. So now I have to times that by 2, which will take me back to 32 root 3. Here we have to sketch a cubic, and we have got some information about its maximum and minimum points. Just in general, you need to know what this looks like. It's a cubic coming in positive, so it should be doing this kind of loop-de-loop. Now they've given us the maximum, so they've told us this point, and they've given us the minimum. So the maximum is at -113, so somewhere up here. Don't have to do it accurately, as long as it's in the correct quadrant. And the minimum is at 2 across 14 down, so somewhere down here. And it crosses the y-axis when x equals 0. So if I make x equals 0, that goes 0, 0, 0, 6. We're crossing here at 6. So we have here something going like this. Go through that. And back down again. And there we have it. Pause the video and have a read of this question. So we see the words equation of the normal, so we know that we're talking differentiation there. And we need to find that equation of the normal. So we're going to pretend we don't know this. This is what we're trying to get to. So just to whip up not this graph, but just a graph, if we have a function, here is its tangent. And here is its normal. And because they are perpendicular to each other, the gradient of the tangent, if that was m, the gradient of the normal would be -1 over m. So I need to find the equation of the normal, I'm going to need a point, and I'm going to need the gradient. And when I have these two things, I substitute them into y equals mx plus c. That's what I need to find the equation of a straight line. It's my ingredients. So do I have a point? Not yet. I now have the x coordinate, but I don't have the y. So let's quickly go and find this point. So we'll find out what y is when x is -4. So I'm substituting it into the function. -4 squared is 16. Minus 20 plus 8. That is 24. Take away 20 is 4. So I have a coordinate now. The coordinate I have is -4, 4. So that's check. I have a point. Now do I have the gradient? Well, I could find the gradient at that point of the tangent, and then I could do the negative reciprocal to find the normal. So I'm going to differentiate to find the gradient of the tangent. That's what differentiation does. So that's going to give me 2x plus 5. And I'm going to say when x is -4, so we want to know the gradient of that particular tangent there. We're going to get that dy by dx equals 2 lots of -4 plus 5, which is -8. plus 5, which is negative 3. Okay, so remember, don't worry about my picture, it was just general. This particular one is sloping downwards there. Okay, so that is the gradient of my tangent. So the gradient of my normal would be positive 1 over 3. So I have the gradient, check. Now I can put it into y equals mx plus c. So I've got y equals the gradient x plus c. I'm going to use this coordinate now. So when y is 4, x is minus 4. So it gives me 4 equals negative 4 over 3 plus 4. Sorry, plus c. I'm going to do this a bit of a long way. I'm going to times everybody by 3 quickly. 12 equals negative 4 plus 3c. 16, just adding 4 equals 3c, so c equals 16 over 3. Whoops, sorry about that. Okay, so what I did here for it cut off is I just multiplied everything by 3 just to get rid of that fraction there. So I've got 12 and 3c here. And then I added 4 to both sides and then divided by 3. Okay, so just send me a message if you don't understand that part. So my final answer is y equals 1/3 x plus 16 over 3. And then they don't want any fractions, because remember we are actually doing a show question. They've given us the answer. So I've got this. If I times everything by 3 now, I get 3y equals single x plus 16, which is what we have over here, which is what we wanted. So I'll say that. It'd be fancy and put QED if you want, like, there you go. Or just leave it like that and they would see exactly where you got it all from. Question number 16. Okay, but revision of the binomial expansion. So I need to find possible values for a. So I'm going to basically expand this using the binomial expansion, figuring out what happens to the coefficient of x to the 4. Okay, let's go. So let's go in ascending powers of x. So we've got 2x to the 0, 2x to the 1. Don't forget to put it in bracket. That's where a lot of people make a mistake. 2x to the 3, 2x to the 4. So I'll stop there. And then I've got, therefore, these are going in descending powers. So I've got a to the 6, a to the 5, a to the 4, a to the 3, a to the 2. Some of you may have noticed that shortcut as you learnt this, as the coefficient should add up to 6. You may have got that straight away. Then we go to Pascal's triangle. This is row, we're going to go to row 6. This is row 0, row 1, row 2, row 3, row 4, row 5, and row 6. So that's multiplied by 1, 6, 15, 20, and back to 15 there. Okay, so then let's do some multiplication. So we have, don't forget, 2 to the power of 4. That's 2 times 2 times 2. That's times 2 again. That is 16 x to the 4 a squared times by 15. And they tell us that it comes out 60. They tell us that the coefficient, actually not that, they say the coefficient is 60. Let's pull out the coefficient there. So it's 16 times by a squared times by 15. They tell us that that is 60. So I'm gonna, I remember we don't have a calculator, so before I multiply that, I can see I could divide that by 60 quite nicely, which is 4. And now I'm going to divide by 16. And now I'm going to square root it. And when I square root, don't forget you're going to get plus and minus the square root of this. And that's going to be therefore, it says work out possible values. So I've got a being a half and a being negative a half. And finally, some trigonometry here. Now, these formulae are given in your formula booklet, but you can see a lot of sines and cosines and things like that. They wanted to change this cos squared into sine squared. So we're going to use this, the fact that cos squared theta plus sine squared theta equals 1. So cos squared theta can be substituted out for 1 minus sine squared theta. So I'm going to do that here to this. So I'm going to get 2 lots of 1 minus sine squared theta, which becomes 2 minus 2 sine squared theta. And we have it. That was quick. And now they're telling us to solve this equal to 3. Now, we can't solve it with cos and sines, but they've already shown us that this can become this. So I'm going to use that. So I'm going to change that into a sine and get 2 minus 2 sine squared theta plus 3 sine theta equals 3. Now, they've been kind to us, and they've shown us how cos can change to sine. They've given that to us, but if we were just presented with this part, the mission is to be able to form a secret quadratic equation. The quadratic equation is in terms of sine. There's a squared version of sine and a single squared version of sine. I wouldn't have been able to form the quadratic in terms of cos, because that's the cos squared. There is no way I can change that sine into cos without introducing tan. Okay, so that's the mission. Spot that quadratic. You've got something squared and something. There's your quadratic equation. We've got sine squared and we've got sine. So when we solve a quadratic equation, it must be equal to 0, and that's negative. So I'm going to hop everything over to the other side to make that a nice positive sine squared. Take away 2 from both sides. And then that should hopefully factorize. That is, yeah, 2 negatives there. We've got -2, -1, which gives us -3. What I tell people is if you don't like trying to factorize that because it looks horrendous, you can think of it as 2x squared minus 3x plus 1, if that makes it easier to stomach. So you're looking at 2x minus 1 and x minus 1. But don't forget, at this point here, we end up with 2 equations. Sine theta is 1/2 and sine theta is 1. Okay, now they want the answers between 0 and 180. So we have here, when sine is 1/2, you know that happens at 30 degrees. And just double check on your sine curve, especially in further maths. Is there another one that makes 1/2? Yes, there is. It'll be 180. Take away 30 as well. So we've also got 150. So watch out for that in further maths. And then where sine theta is 1 only happens here. You see that happening right there at 1/2 of 180 there is 90 degrees. Correct myself straight away. Okay, so that happens right there, halfway between 0 and 180. That is 90 degrees. So if you got stuck on any of that, just send me a message, comment below, like and subscribe, and see you for more when we look at the calculator paper.